Welcome to another edition of Eye on Technology, your glimpse into the science and technology behind Xerox paper and specialty media. And as a special topic today, Xerox replacement cartridges. I'm your host, Christian Redder. In the world today, there are literally hundreds of millions of printers in use, from desktop A4 letter size to tabloid A3 size printers that are used in departmental or enterprise environments. Certainly by volume, HP, Hewlett-Packard is the market share leader, both in Europe and North America. But there are others, Brother, Lexmark, and of course Xerox. Now, irrespective of the manufacturer, at the core of the technology is a toner cartridge and a xerographic cartridge. And it's this particular unit which is the primary consumable in a laser printer. And it's that which we're here to learn more about today. Joining me to tell us about laser cartridges, and specifically Xerox replacement cartridges, is Mike Relyay of the Xerox Media and Cartridge Technology Center. Mike is the senior engineer for this product line. Mike, welcome.
Thanks, Christian. Happy to be here.
Mike, I'm pleased to have you joining me here for two segments of Eye on Technology today. The first here in the studio, where we'll learn from an engineer's perspective more about replacement cartridges and the process that goes into developing them. And then more fully at the Xerox Media and Cartridge Technology Center in your lab, where we'll do a deep dive into the test processes and the protocols that you and your team follow. So let me begin, Mike, with what might seem like a very simple question, but what exactly is a Xerox replacement cartridge?
Well, Christian, Xerox replacement cartridges, or XRCs as we like to call them, are actually Xerox engineered cartridges for non-Xerox printers such as HP, Lexmark, Brother, Kyocera in Europe.
So let me pause you right there. We're talking exclusively about laser print cartridges. Is that correct?
That's correct. Exclusively laser, no inkjet.
Not inkjet.
Correct.
Okay. And secondly, are these new?
Yes and no, Christian. We actually use the empty cartridge that's been used before, but we replace the components in it that are critical to the function of the cartridge as needed.
So what you're doing is using cartridges, I take it, that would otherwise be going to landfill. That's quite an environmental benefit.
Absolutely, Christian. And it's also a benefit to the customer because we're able to reuse that cartridge, offering them a lower cost, as well as a benefit to the environment. And like you said, there are some components that are replaced. Some of them that we'll replace the drum 100% of the time in the cartridge. Also, the toner is consumed during the life of the cartridge, so we'll replenish that also.
And is there anything else? I mean, are those things that are replaced all of the time? You said the toner and the drum.
That's correct. In addition to that, we also replace the chip on the cartridge as an needed basis.
The chip. Now, what is the chip?
The chip, it's a little electronic circuit board on the cartridge. Tracks things like the page count of the cartridge. Also has a serial number on it.
I take it if you didn't replace the chip, even though you replaced all the other components in the cartridge, the chip would still declare the cartridge is spent.
Absolutely. Wouldn't be a very good experience for the customer.
No, certainly not. Other components. You said you replace the toner and the drum virtually all of the time. Are there some other components that you don't replace all of the time?
Oh, sure. Depending on what our analysis determines, we'll replace the doctor blade, the wiper or cleaning blade, also the magnetic roller or the developer roller.
Okay, now, Mike, let me stop you again because I suspect that some in the audience, like me, not entirely familiar with those components, nor necessarily by extension what they do. Could you give us a better sense as to what those components are and maybe how they fit into the overall xerographic process?
Sure. I kind of anticipated that might come up, Christian, so I brought along an animation here on the screen as well as a cartridge that I can show you. Let me show you.
Fantastic.
So, Christian, what we have here is an X-ray animation of this cartridge here, and it shows all the components that we may replace.
Well, Mike, of all the components that you touched on, the toner seems conceptually the most straightforward. So why don't we start with that, and we'll go from there.
Sure. You can see here there's a toner inside of the toner hopper, and all cartridges, Christian, have a toner hopper, regardless of the form factor.
And Mike, that's a good point because really, irrespective of the toner cartridge itself, the xerographic process, it really is the same, isn't it, across the whole line?
Absolutely. So in this case, the toner's in the toner hopper, and this one here has an agitator or an auger inside the hopper, stirs up the toner, provides it to the developer roll here. That developer roll rotates, and the layer of toner on the surface of the developer roll is controlled by the doctor blade here.
Okay, now before you go any further, Mike, just to reiterate, the doctor blade and developer roll, those may or may not be replaced.
That's correct, Christian. These are two components that will be replaced depending on our analysis. Sometimes they're replaced and sometimes they're not. Sometimes we don't need to.
Understood.
Okay. The developer roll rotates and supplies toner to the drum, or OPC here.
Now, what is the drum, by the way?
The drum, OPC, organic photoconductor, is another term that we refer to.
Oh, we do love to abbreviate Xerox, don't we?
It's typically it's an aluminum cylinder coated in a charge transport layer. It just holds a charge and be able to attract the toner.
So what again does it do? I think you said it collects the toner and transfers it. Is that correct?
That's correct. What it does is, like I mentioned, it holds a charge and it'll rotate past the developer roll here, and it'll attract the toner off of the developer roll, continue to rotate, and then transfer that toner to the paper underneath the cartridge.
Okay. Now, the image is transferred onto the paper. It looks like there's another step occurring here. I'm guessing that's some sort of cleaning that's occurring.
This transfer process, Christian, that goes from the drum to the paper is not 100% efficient, and that's typical of any xerographic system. So the residual toner that's left on this drum is then cleaned off by the wiper blade or cleaning blade. That toner then goes into a waste receptacle. The drum continues to rotate past the primary charging roll, or PCR, again another abbreviation. The charging roll puts a nice uniform layer, a nice uniform charge onto the drum. That charge is then exposed by the laser here, which writes the image of the document you're trying to print, continues to rotate to the developer roll again. The toner is transferred to the drum.
And the process starts all over again.
And the process starts all over again.
So, Mike, the cleaning blade, or as you have it here, the wiper blade, that's a component replaced on some cartridges and not others, based, I assume, on your life expectancy analysis.
Absolutely, Christian. That's another component that we may or may not replace.
All right. So let's review briefly. The toner hopper contains the toner, and it looks like there's an auger or something that's stirring the toner. And the toner is then attracted to the developer roller, and I believe you said that the doctor blade is responsible for uniformly applying that toner to the developer roller. And I think we'll have a close-up of the developer roller so people can get a sense as to its size and shape. From there, the developer roller, it looks like it's essentially donating toner to the drum based on the areas of the drum that were written by the laser.
By the laser.
And then it looks like you've got a paper path going underneath, and the paper receives the toner from the drum, and that's what forms the image, correct?
That's absolutely correct.
All right. Now, so far, I'm doing well. The drum continues to rotate, and I think you said there's some residual toner that is cleaned off by the wiper blade, or I guess in more vernacular terms, the cleaning blade.
Yep.
And so that takes care of cleaning the drum. And then the primary charging roller, it looks like that's what's giving the drum a fresh charge so that the laser can write accordingly to it, and the process starts all over.
Correct, Christian.
Now, Mike, tell us a little bit more about the testing that you actually do. I'm sure that all cartridge manufacturers have a testing process, so what is it about Xerox's that makes it so unique?
Well, Christian, you're right. Everybody has a testing process that they go through, but most don't come even close to the requirements that we have here. One example would be our environmental extreme testing. We test in both hot-wet conditions and cold-dry conditions.
Okay, now let me pause you again there. Can you elaborate on this a bit? First of all, what do you mean specifically by hot, wet, and cold, dry, and how exactly do you do it?
Sure. Well, Christian, we actually have an environmental chamber that can actually take the temperature and humidity up or down. So we test at 80 degrees Fahrenheit or 27 C and 80% relative humidity.
So that's tropical, isn't it?
That's tropical. That's our hot-wet condition. We also test at 60 degrees Fahrenheit or 16 degrees C and 15% humidity. That's our cold-dry condition.
Cold-dry, okay. And how about in a nominal environmental condition. Do you do any testing there?
We do, yep. We also have an environmentally controlled lab. It's not as tightly controlled as our environmental chamber, but it is controlled to about 70 degrees Fahrenheit, 23 degrees C, and 50% humidity.
Okay, so that's more of a typical office environment, isn't it?
Correct, it is.
Now, the tropical condition and the cold dry, why are you testing in those environmental conditions?
Well, Christian, we're actually trying to simulate real-world conditions. If you think about someplace during the summer in the tropics, right, it's going to be quite warm and quite humid. And again, think about someplace northern Europe in the winter. It's going to be cool and dry. And these are real-world conditions, Christian, that printers operate in all the time.
Sure. Not everybody uses their printer in a office environment that's temperature and humidity controlled.
That's right.
Yeah. So what sort of testing do you perform as part of the overall process in these environmental conditions?
Well, Christian, like everybody else, we have a 5% document that we run.
5% document?
5% document. It's, we actually use this document here. It's an ISO standard business letter type of document.
Now, ISO.
International Standards Organization.
Okay.
And it's about 5% coverage.
5%?
So 5% of the page is covered in toner.
Okay, so 5% area coverage.
That's right, 5% area coverage, sorry.
Got it.
So, Christian, like I said, everybody has one of these. We have one also. We take it a step further, though. We'll also run at a low area coverage because 5% is about what most customers run. But just because most customers run there, there's a lot of customers who also run at lower area coverage. So we'll do a 2.5% area coverage also, half the coverage.
Okay, because 5% is sort of an average, right? So that means that some are doing more area coverage and others are doing less.
That's right.
But why 2.5%? Why would you? That's a document with not a lot of imaging on it. Why 2.5%?
Well, Christian, if you remember back to our animation, all those components were rotating, and as they rotate, they wear. So with a 2.5% document, you'll get approximately double the yield out of a cartridge, and approximately double the amount of rotations on all those components as well.
Okay, so that's because the toner is being used almost half as much in 2.5% area coverage versus 5%.
That's right.
And so what you're saying is the components will turn more.
And as they turn, they wear. And that wear that they incur will affect the print quality that you get.
Okay, so let me make sure I understand. You're doing a 5% area coverage test in extremes, and you repeat the test, but at 2.5%.
That's right, Christian.
And you're doing that to exercise the cartridge and I think also to evaluate it?
Well, sure. We want to make sure that our cartridge is robust enough and can stand up to pretty much anything a customer is going to throw at it.
Okay, so Mike, that's pretty impressive because I think you're trying to be as good as the OEM.
We really are. That is our goal, to be equal to or better than the OEM.
Equal to or better. Okay, that's a good way of putting it. Anything else you'd like to mention relative to testing that you do?
Sure. We, in addition to our environmental streams that we run tests at, we also do a simulated storage test. So we'll actually take our cartridges and store them at it's about 120 degrees Fahrenheit.
Well, how do you do that? Do you put them in an oven or something?
Actually, that is exactly what we do. We have an
Really?
oven that we can control, absolutely.
So you put the cartridges in an oven?
We put them in on a Friday afternoon, let them sit there over the weekend, come in Monday morning. We'll pull them out of the oven, let them come up to room temperature, put them in a printer, and run a few hundred pages with them to make sure they still work correctly.
Now, Mike, why is it you're baking toner cartridges exactly?
Well, Christian, if you think about shipment from the time the cartridge leaves the factory to the customer, it could sit in the back of a hot truck in the desert somewhere. All the time, the back of the truck could be quite hot.
So what about the other extreme for cold? Because certainly in the climate that you and I happen to be in right now, it's pretty cold out.
Absolutely, Christian. Just like we do a hot storage testing, we also do a cold storage testing. We have an oven. We also have a regular old freezer.
A freezer.
A freezer that we'll stick the cartridges in, again, over the weekend. We'll put them in on a Friday, come in on Monday morning, pull them out, let them acclimate to room temperature, and throw them in a printer to make sure they still print correctly.
And again, this is real world. So you're simulating real world situations where these cartridges can certainly be utilized.
That's right.
Anything else you'd like to share?
Sure, Christian. On top of those two testings, those two tests that we do there, we also do a media stress test. So we'll take printer heavy paper, and we'll run the cartridge. We'll run the paper with that cartridge and make sure that it prints correctly. Again, to make sure that we're the same as the OEM, equal to or better than.
Okay, understood. And so, Mike, you've mentioned the hot, wet, and cold, dry test, and the print coverage stress test, and the hot, cold storage test. That's quite a bit right there. And you said there's more.
Sure, Christian. Why don't we head over to Building 218 and I can show you.
Okay, I'd be delighted. Sounds like a field trip opportunity.
There you go.
Mike, thanks again for your time and for hosting us here at the Xerox Media and Cartridge Technology Center, which I surmise you would call the Xerox MCTC.
That's correct.
And you made the comment, Mike, that the testing standards that you have are really second to none and the most rigorous in the industry. And that's why we're here today, is to understand better what it is you do and what makes these cartridges as good as they really are. Mike, if you would, walk us through the development process for a new replacement cartridge.
Sure, Christian. We do employ a number of test protocols here, and many of them were developed right here at the Xerox Media and Cartridge Technology Center. And I think what you're going to see is some of the most rigorous testing in the industry.
Well, walk us through it, please.
Sure. I've actually got a flow chart over here that I can show you. It'll help explain things a little better.
Let's have a look.
So, Christian, I got our flow chart here that talks about how we do our qualifications, and let's walk through that, would you?
Excellent.
Can we? So we'll start with buying 3 OEM printers, and with that we'll get 7 sets of cartridges.
OEM.
Original equipment manufacturer. It could be HP, Lexmark, Kyocera, whatever brand it is we're working on.
Okay, understood. Thank you.
And Christian, I should point out that that's 7 sets. That's for monochrome, that's 7 cartridges. But for color, that could be 28 cartridges, Christian.
Right, because there's four colors in a color printer, right? There's cyan, magenta, yellow, and black.
That's right.
Okay,
That's right.
Sure. Thank you.
So, Christian, we'll then test those 7 sets for our OEM baseline and measure the results.
Now, what sort of baseline testing do you do, Mike?
Well, Christian, if you recall back to our episode 1, we do our testing in the environmental zones. So we do a hot, wet, a cold, dry, and a mid-mid.
Now, I should point out for our audience, they can't appreciate it, but I certainly can. We're in one of those environmental zones right now, aren't we?
That's right. We're in our low environment right now.
In a test chamber.
In one of our testing environmental chambers, that's right. And it is currently cold, dry.
So tell us a little bit about this room. How does this room work?
So, Christian, I don't know if our audience can see it at all or not right now, but the ceiling is perforated. And we actually have airflow. There's a lot of airflow coming down the ceiling. And off the back wall here, there's a number of vents where the air exhausts. Outside of this room is all the machinery that regulates the temperature as well as the humidity in this room.
Well, and I can certainly attest to the fact that it is cold and dry in here. I'm glad I've got my suit coat on. All right, Mike, let's dive into what exactly it is that you're assessing, specifically in the various test protocols that you employ.
Sure. So I showed you here on the flowchart that we do a 5% area coverage test in the 3 environmental conditions. We use the ISO 19752 test document, which is at about 5% area coverage, and with that we can gather yield data from the cartridge. So using this document, we'll run the cartridge right out to end of life. And if you recall from part 1 that we test in a hot, wet environment, 80 degrees Fahrenheit, 27 C at 80% RH, a cold, dry environment, which is 60 degrees Fahrenheit, 16 degrees C, and 15% RH, and a more typical office-like environment, 72 degrees, 20 degrees Celsius, and 50% RH.
Yes, of course. And as I recall, you made the point of saying that really allows you to create an environment that simulates the types of environments that are common to where these printers are used.
Exactly, Christian. And then once we have our OEM baseline data collected, we know what our targets need to be based on that. And as I said before, we aim to be as good as, if not better than, the OEM.
Okay, so you do 5 tests in total, 3 at the middle environmental level, and 2 at the extremes.
That's right. And then take a look here at the flowchart. You'll also recall this from our conversation in part 1. We run a stress test at 2.5% area coverage. And we do that in the environmental extremes, hot, wet, and cold, dry. And we also gather print quality data, just like we discussed.
And remind us again, Mike, why are you running that 2.5% area coverage test?
Well, we'll do this to understand the life cycle of the components within the cartridge when the toner usage, the usage per page, is low enough to extend the life by as much as twice its stated yield. It also, the usage there has an effect on the print quality. So
relative to print quality, which is as important to our customers as anything, I would think. How do you assess print quality over the run cycle of a cartridge? Do you do this by using the ISO document that you showed us previously?
Of course, in addition to gathering the cartridge yield, however, we also want to assess the print quality of the OEM at various points in its life cycle.
Sure.
The ISO document doesn't allow us to measure a lot of the parameters we're interested in. It's really just a standard business document, mostly text.
It's about as standard a business document as it gets, isn't it?
That's right. So we've created a suite of test patterns that let us evaluate the variation in the print quality throughout the life of the cartridge. Specifically, and I can show you here, we have created test patterns that allow us to measure and therefore quantify a number of attributes. Toner density, for example, how black is the black, banding, streaking, background, ghosting, a number of print quality attributes.
Mike, do you have some examples that we can show our audience?
Sure, Christian. I've got some right here. Here's an example of a document that we use to measure print quality. This particular document we use to assess density. We've got 100% black patches here in the corners. We've also got a density gradient here that we can use to assess the density. Another document that we use is primarily a blank sheet, and what we do here is we're looking for any marks that shouldn't be there, spots on the page, or perhaps background.
Okay, understandable. Oh,
Christian,
look at that.
Here is a document that we also use to assess ghosting, ghosting being a repeat of the 100% area in a halftone. So what we're looking for in this document, and you can see it, is a repeat of this piano key pattern down in the halftone area here.
And I take it that's not the ideal. You don't want to see that.
Well, that's correct, Christian. Remember, our goal is to be equal to or better than the OEM. So if the OEM has that, and it's normal to have some ghosting level in a xerographic process.
Okay, as long as we're no worse, that's the key.
That's right.
Understood.
Christian, here is a halftone document that we use. We use this to assess banding or streaking or any other extraneous marks that may be on the page. We could also measure model on this page.
And I can see certainly some banding on that document.
That's right. There is a small degree of banding here. Finally, Christian, we have a 100% page. Very similar to the halftone. We'll measure banding or streaking. And again, we're looking for marks that shouldn't be there, any extraneous marks.
And I don't know that our audience is going to be able to see that, but I can certainly see some streaking on that document
there
as
is
well,
a little bit.
and a little bit of modeling.
Yep.
Okay.
And
well,
remember,
very good.
Christian, these documents are designed to stress the system, so it's normal for them to show some level of defect.
Sure. You're not seeing these defects typically in the ISO document that you use, are you?
That's right.
Okay.
So let's go back to our flowchart here for a minute, Christian. You can see here that we run the 5% area coverage test in conjunction with the print quality assessment test, and we run in the 3 environmental test conditions. Let me give you an example. For an OEM cartridge with a stated yield of 10,000 pages, our test procedure is to run the image test patterns right at time 0 when the cartridge is brand new. We'll then print 100 of the 5% pages, and Christian, if you remember, we used that ISO document that I showed you in part 1.
Yes, yes.
We'll then, after the 100 pages, we'll print another set of those engineering test patterns.
The same ones you just showed us.
Same exact ones, yep. Christian will then print another 400 pages as an example. And again, now the cartridge has about 500 pages on it. We'll print another set of our engineering test patterns. We'll print another 500 pages, taking us up to 1,000, where we'll again take our engineering test patterns. Christian will then print another 1,000 pages of the 5% document. So
that 5% document is really what you're using to sort of chew up toner, isn't it?
That's exactly what we're using it for, Christian.
Got it. All right. Very clear.
And we'll take our engineering test patterns again at 2,000. And we'll keep repeating this pattern until the cartridge is expended. Okay.
Mike, let me make sure I've got this straight. You run the OEM cartridges in 3 environmental zones, the hot, wet, the sort of mid, and then the cold, dry, to gather yield data using an ISO document at 5% area coverage. And you run the cartridges to end of life, correct?
That's correct.
All right. Concurrently, though, you gather print quality variability data throughout the life cycle by intermittently running scheduled engineering test patterns, the ones that you just walked us through.
That's right.
Then what you're saying is that you run 2 additional tests, if I'm looking and reading the flowchart correctly, at 2.5% area coverage, one at the hot wet and the other at the cold dry, and measure the print quality testing using the same engineering test patterns for a total of 7 tests?
That's right. Total of 7 tests.
Mike, now that you've assessed the OEM cartridge and have a myriad of baseline performance data, I take it then you do the same sort of testing with the Xerox replacement cartridge.
Oh, that's right, Christian. You know, following our engineering guidance, our manufacturing team takes the spent cartridges that we've obtained and builds us a set of developmental cartridges. And you can see here in the flowchart, we bring them to the MCTC, and we'll test them to the exact same protocol that we ran in the OEM cartridge with. And then with that data, we can compare to the OEM results.
And I see there's a decision point on the quality acceptability. I would assume that the results don't always compare favorably the first time, and so this entire process can have several iterations.
Absolutely, Christian. If it's not right the first time around, and sometimes it's not, we'll have to identify the problem, find out what the root cause is, a corrective action, and then retest.
And when you say retest, you're talking about repeating this entire process all over again.
That's right.
So you're generating an immense amount of OEM baseline performance data, and then you're generating an immense amount of Xerox replacement cartridge data. Well, what do you do with it all?
Well, let's go back to the flow chart, and we'll actually measure the results right over here, and we do that by entering the data into our IQOF system.
IQOF. Mike, what exactly is IQOF?
IQOF stands for Image Quality Analysis Facility. It's another Xerox proprietary testing technology. It's really a scanner-based image quality analysis computer program. And when we're done here, I can take you over and show it to you.
Excellent. I'm anxious to see exactly what you do with all this data.
It's even more than that, Christian. It's once we're done gathering the OEM performance baseline data, we move on, as you can see here, to building 7 Xerox cartridges, replacement cartridges, and then we repeat the tests exactly as we do the OEM cartridges. Like the OEM data, the data collected at the Xerox Replacement Cartridge Technology Center is entered into the IQOF and then generates a comprehensive report quantifying the differences between the OEM and the trial replacement cartridges. Based on our report, we'll make modifications if we need to the next trial build and then test them the exact same way, enter the results into IQOF, and then compare the results. We continue with this process until we're satisfied that it meets our expectations.
It certainly sounds as though the IQOF system is absolutely integral to the overall testing protocols, and I'm anxious to see it in action. It certainly sounds as though the IQOF system is absolutely integral to the overall testing protocols, and I'm anxious to see it in action. But before we do that, Mike, is there anything else you'd like to mention about your testing here in this rather chilly environmental chamber that we're in right now?
Oh, there actually is, Christian. You may or may not have noticed, some of the tests we have running here are actually running in duplex mode. We started off doing that just as a way to save paper.
To save paper?
That's right. Yep. And as we were doing it, we found out there was an additional stress on the system.
So it's more stressful on the system running at duplex?
Absolutely. If you think about it, as the paper is going past the cartridge and then turns around and comes back, there's actually more rotations on the cartridge components with duplex than there is with simplex.
And that's because the components never stop, do they? They just keep going that extra bit longer, and that overall accumulates to a lot more wear.
That's right, Christian.
So, and again, I guess that's real world, because so many of our customers we know run printers in duplex mode for any number of reasons. It could be that the job requires it, or it could be that they're simply looking to conserve on paper.
Absolutely.
And I would imagine that you're probably getting the very best readout you can in really stressing the system, because that's real world.
That is real world.
All right, well, Mike, let's take a look at the IQOF system that you've told us about. It certainly sounds like it's a linchpin in your entire testing process.
Let's go.
Well, Mike, here we are at the IQOF station, which, as you described, is the epicenter of quality analysis. Why don't you walk us through the process of what occurs here, and also touch on the hardware as well?
Sure, Christian. As you can see, what we have here, these are some of the test patterns that we produced earlier when we were in the environmental chamber.
Yep, you showed us those before. Very familiar. Right. Thank you.
So I'm just going to start with this one. This one is, if you recall, what we measure here is density. So we have
toner density.
Toner density. That's right. So we have 4 black areas here, as well as a toner gradation here in the center.
So shades of gray, effectively.
That's right. We've also got, Christian, a barcode up here that identifies the test pattern. The system will read and know what to analyze where.
Okay. So, Mike, what do you do with it now that you've got it here?
Let me show you. What we'll do is I'll load it into the scanner here, and we've got, it's a high-resolution, high-quality scanner, loaded into the system, and we'll fire it up on the computer here. Christian, what you'll see in a minute as it's scanning, when it's done, the image will show up over here. You'll see a couple of green rectangles show up looking for the barcodes. Once it finds those, Christian...
The barcode really tells it which document it is, I take it.
That's absolutely right.
Okay.
So it found the barcodes.
There it goes.
Now, Christian, you can see it's analyzing those elements that we were talking about.
Look at that.
Right now,
so it's measuring each individual square, isn't it?
That's right. Measuring them, and then all those results are going straight into our database, which we can run a report on.
And it's recording the density, as you said.
That's right. So let me bring up an example report for you. So this is a chart showing the densities that we just measured.
All right.
Okay. On the left-hand side here, this is density. In this case, higher is better. Higher is darker.
The higher the density, the darker the image, and darkness is good.
That's right.
Okay.
On the bottom here, this is representing the life of the cartridge. So here at the left is beginning at time 0. Over to the right is later in life of the cartridge.
Right, because as you told us, you really measure the print quality from the very beginning when the cartridge is brand new all the way through to basically when it's at or just before end of life.
That's right.
So, Mike, let me ask you: is this a pretty commonly used analysis process in the industry today?
No, this is actually proprietary Xerox software. It really gives us an edge in being able to quantify the defects, and then that gives us an edge in being able to fix them as well.
So, what if the test results are, unsatisfactory? And clearly, these are very satisfactory.
Yeah, in this case, because the pink line here is us. It's higher. We have darker prints in this case in the OEM.
The black line is is the HP cartridge.
Right.
So we're clearly advantaged, and that's ideal. But what happens? And I'm sure during the development process there are times when things aren't as favorable as this.
It happens.
What do you do then?
So let me give you an example here, Christian. So this is background data from that test as well.
Okay, background. I remember that as well from when we were in the environmental chamber, and so that's measuring the sort of the residual,
like a haze over the entire page.
Yeah,
That's right. So in this case, lower is better, and you can see here on the bottom is the HP, and then this magenta line is the Xerox performance. This was clearly unacceptable to us. So, but to your question, Christian, what do we do about that?
Right. What do you do then?
Yeah. Really, the first thing we're going to have to do, Christian, is identify root cause. What caused that to happen? Once we understand that, we can take a corrective action and implement that in the manufacture of the cartridge.
So, Mike, once you've identified a potential solution, I assume you have the manufacturing team build you another set of 7 cartridges, and you repeat the testing that we've just witnessed, and you repeat this process until you've arrived at a satisfactory solution.
That's right, Christian. We'll test another 7 sets of cartridges and perform this testing again.
And with that, let's assume you repeat that testing, and maybe you have to repeat it again, but you get to a point where you've got a good build. At that point, I assume you're ready to go to market.
Not quite, Christian. We're actually looking to repeat that 3 times.
3 times. So
3 times. To us, really, Christian, repeatability is critical to quality. We want to be able to make sure that our manufacturing process is good, our raw components are good, and all these things build into quality.
So just to clarify, you demonstrate satisfactory results the first time. You then go back to the manufacturing team and ask them to produce another build of 7 cartridges, and you run those cartridges through to end of life, doing the same print quality analysis. And assuming that second build is satisfactory, that still doesn't meet the Xerox standard, you need to have a third build produced, and that has to be satisfactory before these cartridges can go to market.
That's right, Christian.
Well, that really is an impressive standard, to be sure. And Mike, once you've completed the development, including all the various tests that we've learned about here, including the repetition of the testing, and we do launch the cartridge, what happens then? Are you done with it and on to the next developmental effort?
That'd be nice, Christian, but in the real world it just doesn't happen. There might be quality concerns that come up. We may have to adjust our raw materials. Let me give you an example that we're dealing with right now. One of our cartridges with the drum that we replace 100% of the time, the supplier changed its factory from Germany over to China. Now,
so you're saying a component changed?
That's right, a component changed in the cartridge.
So that must happen, I would think, with some regularity.
Sure.
It's just a matter of finding the same component from a different supplier, I take it?
Well, not quite. What we'll want to do is we actually want to make sure that component from a different supplier gives us the same performance as what we were using before.
So then what exactly do you do?
So, Christian, what we'll do is we'll take some cartridges that were built previously with the existing supplier, and then cartridges with the new components, test them side by side and make sure that we're getting the same performance out of them as we were getting before.
So you're saying you repeat all this testing again?
That's right. And Christian, these could be with cartridges that we launched 5 years ago. So what we'll have to do, dust off the printers, pull them out of our storage area, and put them back into service.
So, Mike, you're saying that we retain these old printers for years after we've qualified the cartridges?
Absolutely, Christian. We've got a storage area that we keep them all in.
You've got a storage area. You truly retain all these printers.
Would you like to see it?
I would absolutely love to.
Let's take a walk.
All right, yet another opportunity for a field trip.
There you go.
Well, Mike, what you brought me to is really more than a storage area. This is a cage. This is a secure environment, isn't it?
That's right, Christian. It's a secure environment. We need someplace secure to keep our printers. And some of these date back to 1996. They've gone end of life by the manufacturer, and we need someplace secure to keep them.
They're not even available in the market then, are they?
Absolutely not. They've gone end of life.
So, Mike, what I see here is you've got some older printers, as you said, some dating back to as far back as 1996.
Yep.
And then you've got a series of newer printers and some that look like they perhaps were just recently introduced to the marketplace. What else do you have back here?
Well, Christian, another thing you can see we've got here, we have maintenance items for some of our printers. Here's some maintenance items here for some printers. We really need to keep these printers in working order. These are test fixtures to us. We need to be able to take printers out of this area, run tests with them. Take this printer right here, for example. This is a LaserJet 5M. It was the king of the hill for a long time.
The king of the hill, really?
King of the hill. We sold a lot and still sell cartridges for this printer.
No kidding.
No kidding.
Even back from, how old is it now?
This particular device was manufactured in 1996.
1996, my goodness, okay.
So just last month, we had it in the lab running. We had to do a quality audit on it. So we had to dust it off and bring it into the lab.
Now, how long has it been since you ran this printer before then? Do you remember?
Off the top of my head, Christian, I don't remember.
But probably quite some time.
It had been a while.
Yeah.
Yep.
So you have all the components needed in order to bring this printer effectively out of mothballs and to resurrect it and reintroduce it into the perils of the testing protocols that you've demonstrated to us. And essentially, at a moment's notice, these printers need to be ready to be put into action.
That's right. We keep parts around for these printers.
Well, that really is impressive. And you mentioned a bit earlier about quality issues that unexpectedly could crop up.
That's right.
Elaborate on that a bit.
Take, for example, this printer here is the HP 5500. We had a problem come up where as the customers were printing, it would jam right at the fuser. And it's really only happened with specific documents. It had to be very high coverage, right up close to the margin of the paper.
So high area coverage, right up to the margin of the paper. That's a fairly unusual print application, I would say.
It really is. But for those customers who had the problem, it was a severe problem, and we had to correct it. We had to make it right. That's our promise to our customers.
Yeah, that's an admirable promise. So, what was the root cause of the problem?
Well, in this case, turns out the problem was caused by the toner. So what we had to do, we had to pull the cartridges back into service, and essentially, Christian, we had to requalify a whole new toner package.
So again, that means new toner and a whole new requalification process, repeating all the steps that you've elaborated.
That's right, Christian.
Well, Mike, at this point, it's very clear to me, and I suspect it is to our audience, that quality is really paramount, isn't it?
It really is, Christian. We have to be as good as the OEM, but really we strive to be better.
To be better, don't we?
That's right. I mentioned before we do quality audits.
Yes.
And we've got an entire team of people who are just dedicated to doing that. And if you got a second, I'll take you over and introduce you to them.
I would love to meet them. Thank you very much.
Let's go take a walk.
Joining me now is Janet Timmerman, also of the Xerox Media and Cartridge Technology Center. Janet, like Mike, is an engineer focused exclusively on Xerox replacement cartridges. Janet, welcome.
Thank you.
Janet, at this point, Mike has given us a very thorough understanding of the development process of a Xerox replacement cartridge. And I think the audience has a clear understanding of the painstaking efforts that go into developing the cartridges so that they can be the best in the industry. But Mike also told us that Xerox has a strong focus on quality throughout the life cycle of a cartridge. So could you elaborate on that, please?
I'd be happy to, Christian. As you know, our cartridges carry a total performance warranty.
Total performance warranty. Now, what is that exactly?
That's correct. For the lifetime of the cartridge from first print to last, we guarantee that the cartridge will perform to OEM standards.
And is there any risk to a customer should they choose to purchase a Xerox replacement cartridge as opposed to an OEM cartridge?
Well, there's no compromise in quality, and when you choose a Xerox cartridge, there's no risk to the OEM printer warranty. In fact, in the unlikely event that our cartridge should cause any damage to the printer, we will pay for the repairs.
So the total performance warranty then is covering both the cartridge and the printer itself.
That's correct.
That's very important.
Yeah, there's no risk, no worries.
Well, give us an example then, because we were talking about quality and in the life cycle of a cartridge. Say in the manufacturing process, what do we do that's ensuring that the Xerox cartridges are best in class?
Yes, so we employ a series of quality audits during the manufacturing cycle of a cartridge. First, we employ a print test at the manufacturing line. So at the end of the line, we do a print test on 100% of the cartridges, I'll add.
So a print test on all of the cartridges, every single one, 100%. How many pages do you run?
Well, for that particular test, we'll run 5 pages because essentially we're looking for any defects caused by the components themselves, any blemishes that would be considered defective. If we discover these, the cartridge is removed from the line and considered non-conforming, put into recycle. The quality approved cartridges at this point are at that point cleaned, packaged, and only then do they receive the Xerox label, and they're prepared for shipment. In addition to that, Christian, we do something called a post-pack audit.
Post-pack audit?
Well, so recall that the cartridges are now on a pallet ready for shipment.
Sure, ready to go out the door to the customer.
And so we'll randomly select cartridges off the pallet, bring them into the laboratory, and run them to what we call end of life, which is the full life of that cartridge. Say it's 20,000 sheets. We'll print to the end of life until there's no toner left.
Well, why do you do that, Janet? Because you've already done the end-of-line testing where you run the 5 prints.
Well, that's a great question, Christian. But recall that the end-of-life print test was only 5 pages. And that was only testing for blemishes in the components of the cartridge itself. We also need to ensure that the cartridge will print the yield, that is the stated prints that it's
rated for.
Rated for, right. And also that the print quality from that first print to that 20,000th print, or whatever the life of the cartridge is the same from first print to last.
So that's kind of a promise of ours, isn't it?
Yeah, it's a promise to our customer.
The first page looks as good as the last page.
That's correct.
Sure. Janet, anything else you'd like to tell us about?
Well, consistency through the life cycle is our goal. We want our customers to know when they purchase a Xerox cartridge, the print quality from the beginning to the end will be the same, and from cartridge to cartridge, lot to lot, this year and next year, consistency will be the same.
So that the experience that the customer realizes is the same.
That's correct.
There's enough challenges in life without having variability in your printing in the office and what have you.
Absolutely.
Sure. Janet, I assume that prior to launching, you do some testing, packaging, and such that would ensure that the cartridges are kept safe, recognizing that they probably ship via all sorts of different carriers all over the world.
Well, yes, you're correct. We don't stop there. We're constantly monitoring quality, and we recognize that due to the perils of transportation, our cartridges are subjected to a host of
Trials and tribulations, sure.
Yes, that's right.
What sort of testing do you do?
Well, to test for that, we'll conduct routine warehouse audits. So after the cartridges are in the Xerox warehouses, we'll go through and randomly select cartridges off our shelves. And at this point, the cartridges have been through the various methods of transportation to get them on our shelf.
So whether it be, direct ship or common carrier, UPS, DHL, that sort of
Correct.
That sort of thing.
So we will take cartridges and have them shipped here to the Xerox MCTC via common carrier, DHL, FedEx, DHL. So it's subjected to the same type of shipping that our customers will receive the cartridges. And when we get them, we inspect the condition of the packaging. We'll open them up and carefully open the bag to make sure that it's not leaking or damaged. And then at that point, we put it in a printer and run it to end of life again. Again, we want to make sure that nothing has changed from the point when we manufactured it at the assembly line.
And I would surmise that the relative success of these cartridges going through the distribution pipeline is the result of some upfront work that the team does in sort of the packaging design and maybe some other testings that occur.
Well, as a matter of fact, the packaging is an important component. We have a packaging design team that works in concert with our design engineering team here to ensure that the carton is robust and the inner packaging is robust enough to protect our precious cargo.
So I assume you're probably dropping the cartridges from not third-story windows, but probably from a certain height, right?
Exactly.
And shaking them and so forth.
Well, we put it through quite a bunch of torture. We drop it from various heights on the corners and on the ends. We compress it to simulate pallet packing. We will vibrate it to simulate transportation over bumpy roads. And after it's been through this torture test, we see how it survived the ordeal. We'll open the carton and again see if it's leaking or if anything's broken. And if not, we'll put it in a printer and see if it's still printing to specification.
So some people watching this might say, wow, Xerox almost goes to extremes.
Well, it's true. It is extreme, but it simulates real-world testing.
Sure, I would imagine that part of your testing is anticipating what might occur out in the field, so you can design those potential problems out of the product, even if it's things like packaging, which really has nothing to do with the cartridge itself.
Exactly, Christian. We would prefer to have the issues occur here and be able to predict them rather than have the issues occur in the field. And if we observe anything, we will immediately make the corrections here to the packaging or to the cartridge itself to prevent these issues from happening downstream.
Now, despite all of Xerox's best efforts, let's be honest, every company in the world has a problem here and there, and I'm sure that we're no exception.
Right.
So if there are problems in the field, I think that also comes back to you, doesn't it, to deal with those issues?
Well, we do monitor very closely any issues in the field, and we do this via our customer support line, which we have manned with a real person who will answer the phone.
Imagine that, a real person.
A real person.
Hard to believe in this day and age.
Yes, and what we strive to do is resolve the issue on the phone if we can.
So does that happen very often, by the way? I mean, are you really able to resolve issues over the phone?
Surprisingly, yes. I mean, many times we find that it's printer related, either
as opposed to cartridge related.
Well, yes, and
Interesting.
it can be as simple as a firmware update needs to be loaded, or maybe just simply a setting. Or honestly, we've had a few cases where the customer didn't pull the toner seal, the pull strip on the cartridge. So sometimes we can talk them through some simple resolution.
So you said about optimal settings. I mean, as an example, I mean, do customers really call and they've got their printer set in the wrong
Oh,
configuration?
yes. Oh, they might have it set for label mode, or you know, you just don't know. For the first we have a series of questions. We find out what type of media paper they are running in the printer, and then suggest some settings that might be optimal for use of that paper. They may say the print's too light, in which case we're like, well, let's go through, maybe calibrate your machine first, and then let's see, what does it look like? Are you getting any error messages? So we can diagnose even from the error code that shows up on the little LED screen on the printer.
Really? Really? And let's say that it's something you can't fix over the phone, and that probably happens too. What's that process?
Well, there's a lot that we can learn from those types of situations, and in that case, what we'll do is suggest that the customer enclose a print in the carton, tape it up, and we'll email them or somehow send them by mail or fax if they don't have email, a return label at Xerox's expense. We pay for this because we don't feel it should. The customer should have to bear the burden of cost to return a cartridge to us.
So free return.
Free return.
Make the process easy.
At the same time, we place an order to replace that cartridge, so it will be delivered to their door within 2 to 3 days. They'll have a new cartridge.
So you're saying that we not only do we give them a return label, and that's at Xerox's expense, but simultaneous with that, we have a new cartridge en route to them.
Absolutely. We understand that our customers have a business to run, and we don't want to cause them any stress or downtime.
Well, you know, Janet, that's also an incredibly impressive promise to our customers, isn't it? Because, you know, ultimately, we recognize that people want to print with ease and with facility, and they don't want to be mired down with problems with a cartridge, whether it be Xerox's or quite frankly anyone else's. And the total performance warranty, that really sums it up, doesn't it? That's probably the best in the industry.
It is. It is the best. And we recognize that there's a choice of cartridges out there, and we want to make sure that our customers choose Xerox.
Well, and Janet, based on what you've told us, and certainly your colleague, Mike Relyay, it's clear that Xerox has a deep commitment to quality. And I first of all like to thank you for spending time with me today, and also please extend to Mike Relyay my thanks. And so for Eye on Technology, I'm Christian Rutter, and look forward to seeing you again.